Okay, guys, we'll do the check your understanding on page 400. Refer to the previous check your understanding about Miss Desai's special multiple choice quiz on binomial distributions. We define X as the number of Patty's correct guesses. So we're going to find the mean and the standard deviation, okay, and then we'll do something else. So before we do that, come on down here. Wrote, again, she's had a 10-item multiple choice quiz. The answers were A through E. So the probability of a correct answer is 1/5. And X is the number of Patty's possible correct guesses, okay? I did binomial PDFs for every single possible number of correct guesses from 0 to 10. And if I add these up, it should equal 1. It actually equals 0.99986, which is close enough to 1.0, okay?
Should be a little squiggly equal sign.
It is a squiggly. All right. If we look at this in terms of a graph, okay, with our x's, our 0 to 10, our x's down here and our probability of x's, we can see the peak is right here at 2. So it'd probably go like this and definitely be right skewed, okay? The mean, going down here, the mean is simply what you would expect. If you've got 10 questions and there's a 1/5 chance of getting them correct, you would expect 1/5 of 10 to be correct, right? So our mean is simply n times p. So we had 10 questions and the probability of getting them correct is 1/5. So you would assume you would get 2 correct, I don't want to say guesses, 2 correct answers, which corresponds to my binomial PDF of getting exactly 2 correct. This is the highest probability, okay? So that's my mean, or my expected value, or however you want to call it, okay? My expected outcome, my expected value, the mean of the binomial distribution, okay? So how we interpret that, like any other mean, if many students took the quiz, we would expect the students to get about 2 answers correct, okay? Standard deviation is the formula square root n times p times 1 minus p. So it's our number of trials times our probability of success times our probability of failure, just square rooted. Okay, so probability of success, probability of failure. Put that in the calculator. So I have 1.265 questions, or correct answers as my standard deviation. So again, if we interpret it, if many students took the quiz, we would expect the individual scores to typically vary by about 1.265 correct answers from the typical 2 correct answer mean. Okay, it's pretty straightforward. All right, then it asks up here, what's the probability that the number of Patty's correct guesses is more than 2 standard deviations above the mean? So we want to go 2 standard deviations above the mean. Okay, so the mean was what? 2 plus 2 standard deviations, which was 1.265. We throw that in the calculator and we get 4.53 correct answers. Okay, so I want to know the probability that she's going to get 4.53 correct answers. Now this is a random variable. Random variables can't be decimals. Okay, so if we think about .53 is right here, so we want more than 2 standard deviations above the mean. So we want 5, 6, 7, 8, 9, and 10. Okay, we don't want 4 because that's not more than 2 standard deviations above the mean. So this just ends up being the probability that x is greater than or equal to 5. And again, I could go back and total up 5, 6, 7, 8, 9, and 10's PDFs. 5, 6, 7, 8, 9, 10, and 10's PDFs, and I would be done. That work would give me my answer, okay, whatever that is. And we can do that in a second. Well, whatever, you can check that when you get the answer. But we're going to use a binomial CDF, okay? So again, a binomial CDF is cumulative, but it has to be to the left. So as we saw in my chart here, all of these probabilities add up to be 1. So if I take 1 and subtract all these, I'll get that, okay? Not that I couldn't add those up, because you could, okay? So this is really 1 minus the probability that x is less than or equal to 4, okay? So again, I'm going to do my binomial CDF. It asks for the number of trials, the probability of success, and then at what point do I want to start my left accumulation, okay? So I want to start at 4 and accumulate 4, 3, 2, 1, and 0, okay? Stick that, gotta do 1 minus, okay? Stick that in the calculator, and you get 0.03279. And I assure you, if you put those in the calculator and add them up, you will get 0.03279, or pretty darn close to it, okay? So there's about a 3.3% chance her score will be more than 2 standard deviations above the mean score. Okay, probably not going to happen. Okay, okay, I think that's that for that one. I believe there's one more. See you next time.